Students, so far we have seen the particle velocity and the acceleration in a progressive wave. In today's class, we will see the relationship between the particle velocity and the wave velocity in a progressive wave. I hope students in the class we have discussed what is a particle velocity as well as the wave velocity. But now we will see the relationship between them in a progressive wave. Alright. So, as usually, let us consider the displacement of the particle in a progressive wave B. The usual expression that we put for the displacement, that is y equals to a sine within bracket omega t minus kx plus minus phi bracket close. Okay. So this is our usual expression of displacement of the particle in a progressive wave. Okay. So if this is the displacement, the y means the displacement of this particle. So what will be the particle velocity? So the particle velocity will be v equals to del y by del t. Just think it in a mathematical way that if you want to find the velocity, you have to differentiate the displacement for one time. So what will be the value of del y by del t? Just do the differentiation. It will be omega within omega a cos within bracket omega t minus kx plus minus phi. That means omega a will, as it is a constant, it will come out, and sine, differentiation of sine will be cos, and the rest of the term will be as it is. Alright. So what we will do now, we have done the del y by del t, that is v, the particle velocity. Now we will find del y by del x. It was with respect to t. Okay, see, it is we have done the differentiation with respect to t. Now we will find del y by del x. That means we will differentiate it. That means we will differentiate this y with respect to x. So what will be the value? Del y by del x equal to minus k a cos within bracket omega t minus kx plus minus phi. Okay. The simple form of differentiation, that means here we are doing with respect to x. So minus ka will come, since it is a constant, it will come outside the bracket, and inside the bracket omega t minus kx plus minus phi. Simply from this part, from this full part will be here also. Okay. Okay. So what we have done, we have done the differentiation. We have done the differentiation with respect to t as well as with respect to x. Okay. So now what we will do, we will divide this v, that means this part, by del y by del x. Okay. V divided by del y by del x, simply mathematical calculation. So what will be the value? Minus omega by k equal to minus big V. Explaining this step, what we are doing? We are dividing V by del y by del x. That means this we are dividing. Okay. This value we are using here. Alright. So V divided by del y by del x equals to what was our value of v? This part, that means this part divided by this part. So your value will come to as minus omega by k. And students, if you remember the angular wave number that we have studied previously, so from the angular wave number we can write one value, that is, I'm writing it. Suppose if v, this v be the wave velocity, as v is the wave velocity, so k will be equal to omega by v. What is this? K stands for? K stands for angular wave number. So k equals to omega by big V. That is the wave velocity. This big V, we are writing it here. Okay. So since in our previous step we had minus omega by k, that means V will go up in the numerator and omega by k. From this we are writing it as, just a minute, from this part we are getting it as v equals to omega by k. So for that reason we are writing the value of v here. Alright. So see, so this our mathematical, this part is over. So now what we will write finally? So therefore your small v equals to minus big V, this is your wave velocity, del y by del x. Okay. So this is basically the relation between the particle velocity v. This is your particle velocity and this I have already written this as your wave velocity. Understood? Please don't get mix it up. Particle velocity should be always written by small v and your wave velocity by big V. Alright, that is capital V. So in case of transverse wave, the direction of particle velocity is always perpendicular to that of the wave velocity. In the initial class of this transverse wave, we have seen